Okay, so we've now brought up over 200 of those cores on deck, so that is equivalent to almost coring through about 1.8 kilometres of rock in the Ross Sea.
Antarctica is the largest freshwater reservoir of the planet, and some sectors of Antarctica are melting fast. Our mission, our target here is to reconstruct past warm times.
To see how the ice sheets responded at these different warmer than present climates.
So many brains kind of coming together, which is really amazing, because I could do a lot of things with geochemistry, but I can't describe the sediments really well. I can't measure the paleomagnetics. I can't look through a microscope and identify all the organisms living there. So all of us bringing this knowledge together.
It's very important to select your site, and seismic can help to determine the drilling depth by calculating the speed of sound in the water and in the sediments.
But by doing this, you are able to trace them laterally, but you don't know exactly which type of sediment it's actually here.
Then you need to drill.
So after the cores get cut in half, we look at the color, some of the texture, so the grain size, and what types of sedimentary structures are there.
And then eventually all of that goes into defining the major lithologic units for this section, which is kind of the framework that we think about.
Once the lithologic units have been defined, we all come together for a science meeting to review the results, and all of the other laboratory groups analyze their data.
The second site, we're looking at the Pliocene warm period. Planetary temperature was 2 to 3 degrees Celsius. And those are temperatures we're going to get to within 100 years. So how much does that oceanic warming act to melt an ice sheet? Can we see them triggering an ice sheet retreat from this outer shelf environment?
Second side, we have seen lots of diamictite, whether it is class rich or class 4, muddy or sandy diamictite.
Igneous rocks and metasedimentary rocks, fragments of chert, just lots of different stuff that had obviously been brought by the glacier to the site.
And in between there are thin intervals of diatom ooze, and they are the kind of open water conditions, which is similar to the situation today.
In addition to coring and bringing material up from beneath the seafloor, we also do what's called downhole logging. We lower tools down into the hole, and those tools are then pulled up on a wire line and making measurements as it's pulled up.
They're just rigging up the first wireline tool string, the triple combo. This is really important, especially at this site where we had really bad recovery at the top of the hole. This logs all the material in situ.
The seismic reflection data, the core data, and the downhole log data put together a history with a lot more accuracy.
We are going to the third site now, which is very unique because it's deep enough to actually preserve the fingerprint of the currents much more than the fingerprints of the ice sheet.
At the first two sites, the cores had a lot of really compacted sediments, and I'm really excited because these sites have more fine-grained clay-like sediment and more water trapped inside those sediments in what we call the pore spaces. So we squeeze that water out, extract it in this syringe, and then I distribute those water samples into the different vials for different measurements that we make on the ship.
The third site is trying to understand, why did we have such warm waters next to Antarctica? Was it a uniform warming from the top down, from the atmosphere into the ocean? Or was it due to changing ocean currents?
We also celebrated the halfway point in our cruise, at which time we have what's called a hump day party, then have a dance party.
Basically, what you could call a dream for scientists being on such a ship is everything is available, infrastructure is perfect, logistic is as smooth as you can think, and you have all the scientists together. We only need to think about the science.
Anytime you come to Antarctica with the Joyous, you discover something special.